welcome back. Today we're going to talk about adding and subtracting fractions. If we're looking at adding and subtracting fractions in terms of a manipulatives model or a modeling, visual modeling, what I've got here is I've got a couple of fraction bars, and what I'm going to do is I am going to color in a specific number of them to kind of give us an idea of what we're talking about. So let's say we had this rectangle and there were a couple colored in this one here and one colored in the first one. And what we could do is we could set this up as an equation. Well, if we're adding the pieces together, we can obviously see that we have 1, 2, 3, 4, 5 pieces. So what is represented here is one of them out of 5, and this one is 2 out of 5. And so if we add those two together, we're going to end up with 3 pieces, 2, 3 pieces out of the 5. Now, our ultimate goal is to use that as a springboard into talking about it mathematically. So what we're going to do is we're going to say, what if I made this an expression? And I talked about this mathematically. Well, the thing that often trips people up is they start to add the denominators and all that kind of stuff, but really we're talking about how many pieces do we have. And so here it's 1/5 plus 2/5 is equal to 3 of the fifths. Same thing works for subtraction. And so if I have 2 of these and 1 of these, and I set this up to be a subtraction problem, what I'd end up with is 2 of them minus 1 of them would obviously be 1 left. And if I wrote that as a fraction, it'd be 2/3 minus 1/3 equals 1/3. Okay, so that's the basic gist. That's what it looks like if we talk about it in terms of the model's approach. And that always works. So for adding and subtracting fractions, the thing that we need to check out here is the fact that we had the common denominator. So if we have, A over B minus C over B, we get A minus C over B. Or in other words, that would be like 3/4 minus 1/4 equals 2/4, and obviously we can reduce that to 1/2. So that's what we're basically working with here. So when we look at these problems here, I'm going to do a couple of them and let you fill in the rest. Okay? So notice here, without using models, what I'm looking at is ninths. And if I have 2/9 plus 5/9, I know that my answer is going to have ninths on the bottom because I'm still, I'm talking about those rectangles divided into 9 pieces. And so I'm going to end up with 2 plus 5, which gives me 7/9. Same thing for my eighths here. If I've got these eighths, I'm going to end up with eighths on the bottom. So 3 plus 1 would be 4. And I can reduce that, noticing that there's 4 out of 8 would be the same as saying, 1 out of 2. And I'll leave you this one to be done. Same thing for subtraction here. I'm going to skip to this one. If I've got 7 minus 1 over 9, my denominator stays the same. It's as if I've got those rectangles and I've got 7 pieces minus 1, so that would give me 6 of them. And I know that if I divide the top by 3 and the bottom by 3, that's going to give me 2 over 3. Okay, so that's the basic gist of how this works when we have common denominators. The tricky part comes when we have different denominators, and what I'm going to do here is I'm going to model this with the same kind of fraction bars that we had before. I've got some fourths here, some eighths here, etc. So what I need to do is this. I'm going to say, what if I've got 3 of these? Okay, and I'm going to say I've got 3 of these as well. If I wrote this as an expression, I want to add these. And if I'm writing this as an expression, what I've got is 3/4 plus 3/8, right? Because it's this one's out of 8. and the other one's out of fourths. So I can't really add those. And so what I'm going to do is I'm going to find a common denominator. Well, if you have any experience with fractions before, you can see that we can do a certain little trick here. We could multiply the top and bottom by 2, but let me look at that, what that means visually. I'm just going to draw a line down the middle here. Okay? And notice what happens. Really, what happens is I just divided these all in half. So I made eighths. Mathematically, what that means is if I divided each of these in half, that means that one of them became 2. So I really said I got eighths on the bottom by taking each one of them, and there were 3 of them, and I multiplied it by 2. So out of 1 came 2. And so really what I ended up with was 6 eighths. Well, look what happens now. If I have this expression, I can simply count up the pieces that I've got. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 of them. And I'd have 1 extra. Okay, so if I added those, I would end up with 9 eighths, or 1 and 1/8. Okay, so that's the theory behind common denominator. I'm finding something common that they could both have. So let's look at this from a strictly mathematical approach. Fractions with common denominators. If I have, for example, 1/6 plus 2/3. I don't have a common denominator. What I am going to do is I'm going to say, if I look at the 6 and the 3, what's common? Well, I could do something like this. 1/6 plus, and then I could take my 2/3, and I want to get sixths on the bottom. So I'd multiply it by 3 over 3 to get sorry. Really, I'm going to multiply it by 2 over 2. Multiply by 2 over 2 because I want sixths on the bottom. So I'm going to have 6 and then 4 on top. So my new expression is 1/6 plus 4/6. See how nice that is now? So my sixths are going to allow me to add them together. Even though it's really thirds, it also can be expressed as sixths. So let's look down here. I've got fourths and I've got thirds, and so I need to look at 4 and 3, and I say what goes into both of them, or what do both of them go into. So if I didn't immediately know, something I could do is I could say I could multiply these out. So 4 times 1 would be 4, then 8, then 12, then 16, then 20. And then we go 3, 6, 9, 12, 15. I multiply them out. The multiples are going to tell me what they go into. So 4 and 3 both go into 12. Well, what that means for me is I can say 3/4 and 2/3. I'm going to convert them. So if I'm going to convert fourths to twelfths, I need to multiply by 3 over 3. So it's going to give me 9 over 12. And 2/3 is going to become twelfths, so I need to multiply by 4 on bottom and also 4 on top. That would give me 8 over 12. And you see, if I rewrite this expression here to be 9/12 plus 8/12, that's going to give me 17/12, or 1 and 5/12. See how that goes? Okay. Same thing works for subtraction. Let's do the subtraction one over here. I've got my eighths and I got my thirds, so I can do 8 and 3. 8, 16, 24, 32. Those are my multiples. 3, 6, 9, 12, 15, 21. Anything common yet? No, not yet. So then I squeeze another one in here. I got 24. So I know that 24 goes in. So both. Well, if I've got 7/8 and 2/3, what I can do is I can say, what do I need to multiply these by to get what I want on bottom? So eighths, I want to end up with 20/4. So I need to multiply this by 3 over 3. That gives me 21 over 24. Asking the same question down here. If I want 24s on bottom, what do I have to multiply to get there? Well, it's 8. So 8 on top, 8 on bottom, 16 over 24. And I can subtract. So I've got 21 over, and again, this expression here, I'm rewriting it. So 21 over 24 is 7/8. They're equivalent fractions. 16 over 24 is 2/3. That's an equivalent fraction. So I end up with 5 over 24. That's using common denominators to add and subtract fractions. Thanks for watching, guys. We'll see you next time.